All right, guys, today we are looking at lesson 6.3, two-way tables. So a two-way table displays two categories of data collected from the same source. So here is a two-way table that is looking at whether students studied or not, and then if based on that, if they passed or failed. So the first question says, how many students in this survey above studied for the test and passed? So studied for the test and passed happens to fall right here in this box. So there were 21 students who studied and passed. The next one says, how many students in the survey above studied for the test and failed? So studied for the test and failed actually happens right below that. So if you line up studied and failed, you would see that that was one student. And then the last one there says, of the students who did not study, how many more failed than passed? So if you're looking, of the students who did not study, there were a total of 8 students who did not study. 6 failed and 2 passed. So that means there was a difference of 4. The next idea here says, find the marginal frequencies. Marginal frequencies are the totals. So if you're looking, it says how many students studied for the test. If you add up the number of students who studied, that's this column here, you would end up with a total of 22 students who studied. How many students failed the test? Failed the test is going horizontal here. So there were a total of 7 students who failed the test. And then it says, how many students were there in total? Well, if we're looking at these different totals here, this was 22, this was 8, this one was 23, this one was 7. So either way, if you had 23 and 7, or if you had 22 and 8, your total is 30. So there were a total of 30 students who were surveyed for this poll. All right, in the next example, we are going to make our own two-way table. So it says you randomly survey students between the ages of 12 and 17 about whether they ride the bus or not. The results are shown in a tally sheet. Make a two-way table. So we're going to divide this two-way table here. So we're going to say rides bus, or does not ride bus. Okay. And then on the side, we're going to split it up into the ages that they had. So the categories were 12 to 13, 13 to 14, and, that should be 14 to 15, 14 to 15, and 16 to 17. Okay, and then our last one that we want to include on the side is our totals. Alright, so now we're going to copy that information. So if I'm looking at rides the bus, we have 5, 10, 15, 24 for 12 to 13. I have 12 for 14 and 15. And I have 14 for 16 and 17. If I look at does not ride the bus, I have a total of 16, 13, and 21. So then if I look for my totals, I'm just going to add those up. So 24 and 16 adds to 40. 12 and 13 adds to 25. And 14 and 21 add to 35. In total, right, that would be 100 people. If I'm looking at total for rides the bus, I'm going to add 24, 12, and 14. So I get a total of 50, which makes this total also 50. So that would be my two-way table to represent the data. All right, looking at example 2, completing a two-way table. Here we're going to use the totals to subtract to find our missing pieces. So if I'm looking at, in that first one, the total number of females, I'm going to do, there were 137 total females and 24 participated in a triathlon. So if I do 137 minus 24, I can find out that 113 did not participate in a triathlon. To find the total number of males, I can do the total number of people, so 306 minus 137, to find out there were 169 males. Then to find the number of males who participated in the triathlon, I could do 169 minus 142 to get 27. And then I could add those up to get my other totals. So 24 and 27 gives me 51. And then 113 plus 142 gives me 255. All right, now I'm going to do that same thing for the dual enrollment student and whether they are a sophomore or a senior. So I'm going to figure out my total on the bottom by doing 550 minus 432, which tells me this is 118. To find the number of seniors who were not dual enrolled, I'm going to do 432 minus 247, so I get 185. To find the sophomores who were dual enrolled, I'm going to do 118 minus 83, which gives me 35. And now I can find those other two totals, so 35 plus 247 gives me 282, and 83 plus 185 gives me 268. All right, example, I guess that should be example 3, really. Making a two-way table. You conduct a survey that asks 397 students in your school about whether they have played a musical instrument or participated in a sport. 118 students have played a musical instrument, and 57 of those students who have participated in a sport. 34 of the students have not played a musical instrument or participated in a sport. Organize the results in a two-way table. All right, so in my two-way table here, I'm going to play, played a sport. I'm going to reread that. Played a sport. Or did not play a sport. And then on the other side, I'm going to say played a musical instrument. Or did not play a musical instrument. And then, of course, I'm going to include my totals. All right, so now that I'm set up, I'm going to go back through. It said you conduct a survey that has 397 students. So I know the total number of students was 397. It said 118 students have played a musical instrument. So for played a musical instrument, my total is 118. And 57 of those students have participated in a sport. So 57 played both a musical instrument and a sport. 34 of the students have not played a musical instrument or participated in a sport. Organize the results in a two-way table. All right, so that's the information I have. So now I need to do some adding and subtracting to find out my other pieces. So if I do 397 minus 118, I can see my total for people who did not play a musical instrument is 279. If I do 279 minus 34, that would tell me 245 played a sport and not a musical instrument. 118 minus 57 tells me 61 played a musical instrument but not a sport. And then 57 plus 245 tells me 302 played a sport. And 61 plus 34 tells me 95 did not play a sport. So that is my completed two-way table, and that is the end of our notes. So you can return to the agenda to find out what you need to do next.